In this video, we're going to see how to use Retrofit to easily parse JSON to a plain old Java object, or in this case, it's going to be a Kotlin data class. Why do we use Retrofit? Well, it makes threading very easy for us, and in our case, we can use Kotlin Coroutines. It handles the network connectivity, and it handles the parsing of raw data to a series of data classes. So let's take a look at an animation I've shown before, but this time I've updated it to discuss Retrofit and the role of Retrofit in a live data view model architecture. So Retrofit is this green tube over here, and essentially what Retrofit is going to do is take a source of some JSON data, which is essentially text, consume it, and parse it into a series of objects of data classes. Then it's going to take those data classes, and we'll wire up this part. This actually isn't Retrofit, but it's going to make that data available to live data. Live data can then be observed by our user interface. The nice thing about using the observer pattern or observability with live data is that the observer is lifecycle aware of the Android application. So if an application goes to pause where it's obscured by something or it gets backgrounded, it automatically stops observing. Where if the application is active, it continues observing. Or if we have something set up as an observe forever, it will observe regardless of the Android activity lifecycle. So when the next piece of data comes through Retrofit, it goes to those things that are actively observing. What do we need to do to set this up? Well, a few things. We need to add dependencies for Retrofit. We need to add permissions to our Android manifest. And then we need to determine our endpoint, or in other words, the location where we're going to be receiving data. I'm going to use a plant places data source for my JSON data, which is plantplaces.com/perl/mobile/viewPlantsJSONArray.pl. And you can see here that we have a lot of plant data that's set up in this JSON data source. If you need to find some data to parse, I'd encourage you to take a look at JSON services, which is just a list of JSON services that I found handy before. Also, open data initiatives like the Cincinnati Open Data Initiative. That's a good place to find this JSON data. So the role of Retrofit is to go fetch this data, parse it into objects of data classes, and then make those data objects available to us. And for us, we're going to consume that with live data. We will save the live data discussion for a later lecture. This lecture, we're purely concerned with the Retrofit parse. So, we left off with determine endpoint. Next, we need to create a DAO, and we need to tell it which endpoint to hit. Then we need to create a data class, and we need to annotate that as well. And then we need to create our Retrofit client instance. Now, we also said we're going to be doing test-driven design with this, and we've already created a test-driven design test in a previous video. So we'll start with that, and then we'll iterate through these other things that we need to do. Let's look at our class diagram, and let's pay particular attention to the classes that we are going to need to make in this video. First of all, plant service. That's the class that we're testing in our unit test that we've not made yet. Next, iPlantDAO, and finally, Retrofit client instance. Let's start with our dependencies. So Retrofit is a third-party library that we are including in the project, and these are some dependencies that we can use. As always, these are current at the time of me recording this video. They likely have changed in the time that you're going to watch the video. So I encourage you to just do a bit of research and grab whatever the latest is. I'm going to navigate to build.gradle in the app project, and I'm going to add these dependencies. And then I'm going to do sync. I like to do this first because sometimes it takes a while. So if we can possibly add those dependencies, let's do them now. Next, I'm going to double shift and go to Android manifest. At the top of this manifest file, I'm going to add a uses permission. And we'll say android.permission.internet. This simply means that we have access to the internet, and that kind of goes without saying with apps these days. But nonetheless, that's what's considered not a dangerous permission, because apps typically do access the internet, so we simply need to declare it here. We don't need to ask the user for it. And then anything that's declared here will show up in the App Store, so the user will know that this app needs internet access. And that takes care of our dependencies. Next, our DTO, or our data class. this is going to model the JSON that we are consuming. I've taken a sample of this JSON data from our endpoint and I've pasted it into jsonviewer.stack.hu so that we can visualize it. If we go to the Viewer tab, we see that we have square brackets, which indicates an array or some repeating data. Let's take a look at the data. We see ID 3121, genus begonia, species is unknown, cultivar, and then common, and then a few other attributes we're not going to worry about just yet. Now, if we keep going, we see ID, genus, species, cultivar, common. And for each of these, we see ID, genus, species, cultivar, common. So each of these elements of this collection have these attributes, and the attributes have different values. And that's the definition of class and object. A class defines the attributes, and an object gives them value. So we simply need a data class that looks like this and has these attributes, and then Retrofit will go in and will parse the JSON into these objects. So you can see it here, ID, genus, species, cultivar, common. You can also see it in the text view, ID, genus, species, cultivar, common, and several others. It's just a little easier to view when you see it in the Viewer tab. The good news is we have a head start on this. If you recall, a few videos ago we made a unit test using test-driven design where we defined a plant data class. And you see this has genus, species, and common. We can add a few more items here. We can say var cultivar, and then we'll go ahead and give that a default of just empty string. And we'll give it the data type string as well. And then we can say var ID of type int. We'll give that a default of 0. As long as these names match up to the names in our JSON stream that we see here, Retrofit can typically figure it out. But if the names don't match for some reason, maybe we're mapping to a DTO that's already been created or data class that's already been created, or maybe the capitalization is off, then we can use an annotation called serialized name. And in quotes, we pass in the name that can be found in JSON. We simply put that before each attribute so we can specify that genus links up with the genus name, and we could continue and do this for species, cultivar, common, so on and so forth. But that serialized name effectively gives us a mapping between our attributes and the attribute names that you'll find in JSON. And a little description here if that helps. That takes care of our DTO. Now let's run back to the test-driven design unit test that we created and use that to figure out what we want to create next. We know we need plant service, we know we need the plant DAO, and we know we need retrofit client instance, but let's just follow along with the unit test. The reason I want to do this is we notice that the unit test has red lines. And red lines mean stop and fix it immediately. So we tidied up the DTO, that's great, we tidied that up, but now let's focus on this class called plant service. So, plant service should live in the com.myplantdiary.service package. Well, let's see, I have app plant diary, but I do not have a service package. So let's add a new package, app.plantdiary.service, and inside of this, new Kotlin class, plant service. Now, let's go back, because we have this plant service class, let's go back to our test and see if we can clean this up a little bit. I hit Alt-Enter above plant service and I choose import. And notice that those red lines go away. So we're starting to build towards a compiling unit test. But now we got a new red line. New red line is this fetch plants method. So it's saying, well, I know what plant service is, but unresolved reference fetch plants means there's no fetch plants method on that plant service. So let's go back to plant service and make the fetch plants method. There's fetch plants. Now, okay, we have another item, type mismatch required list plant found unit. Unit is kind of like it doesn't return anything. And what it's telling us here is, wait a minute, fetch plants should be returning a list of plant objects because we're assigning that to all plants. And all plants data type is a list of plant objects. Okay, that gives us a bit more information. We know in Kotlin we'll put a return type of a function after the function following a colon. So we'll say list, plant, and then question mark means this is a nullable type. Now it's asking us to import. Let's go ahead and import. Now this class does not compile now because we're saying that it returns a list of plants, but we're not actually returning any plants. To return plants, we need to engage retrofit, which means we need to take a look at some of those dependent classes that our plant service is going to need. Let's go ahead and create those dependent classes. First, we'll go with the bootstrap class RetrofitClientInstance. This one is pretty much boilerplate. So this is one where we don't need to go through every line individually, but just take a look at what I do and copy, paste, alter it as you need. That's easier than building it up from scratch. We'll go to our root package and new, let's go with a Kotlin filer class. And we're going to call this one an object. An object is kind of like a singleton or a static class would be in Java, where we don't create objects out of it. There's just basically one that lives. We'll call it RetrofitClientInstance. Now within this static class or singleton if you wish, I'm going to paste this is the part where I say it's a bit of boilerplate. We're making a factory here that's going to initialize retrofit and then return retrofit to us. We need to provide it a base URL. The base URL is typically the domain that we are invoking. So I'll grab plantplaces.com and paste. Then when it creates retrofit, it starts with that base URL and it returns retrofit. Moral of the story here, this is what I say is boilerplate. The only thing you really need to change is this base URL here. Aside from that, it's pretty much copy-paste. And so that gives us our retrofit client instance. Our DTO is complete. Our service is almost complete, or at least it's started. Next thing we need is this iPlant DAO. Good news, the DAO is probably the easiest thing we're going to create. We start by creating a package because we don't yet have a DAO package. And then inside of this, we're going to make a new interface. Interface, iPlant DAO. Now remember what an interface is. An interface is simply a list of methods. So that's why I say all we need to do is define this interface, and Kotlin will actually work out the implementation of this interface for us. Fun, get all plants. And we want that to return what? Well, we want it to return an array list of plants. So we need to import the plant object, or the plant data class rather. There we go. One more thing we need to do, because we're using this with coroutines, we simply need to wrap this with one more item, and that is call. And then Alt-Enter and import. Next, we apply the @get annotation. All uppercase. And do you remember that base URL that we indicated earlier? Well, in the @get annotation, we simply indicate the endpoint, which is everything that comes after that base URL. Put the base URL and the endpoint together, and we get this entire URL that gives us our JSON data. So I simply put that endpoint in the quotes here. And believe it or not, we're done with the DAO. That's it. So DAO is complete. Data class is complete. The Bootstrap Retrofit client instance is complete. All we need to do now is finish our plant service. This one does get a little bit tricky because we do have to deal with coroutines. I have a separate video that talks about coroutines and the different things that coroutines do. So I don't want to repeat all that here. I encourage you to watch that for some background. Just a quick refresher though, we typically have our UI, and our UI will kick off a long-running process in a different context. In this case, for network operations, we'll kick that off in dispatchers IO. That means we can render the UI, then we can go fetch the data. Then by using model view model with live data, we can update the UI because the user interface is observing on our live data. And this is a really efficient way to draw a responsive user interface, and then in the background, fetch data, and then use that data to update the user interface when the data are ready. From this, just remember dispatchers IO. Remember, that is the context where we are going to be doing the actual network operations. So we can specify that in our fetch plants function by saying withContext dispatchers IO. And then whatever happens in here will happen in that separate dispatchers IO context. Note that we get an error message here that says suspend function withContext can only be called from a coroutine or another suspend function. A suspend function is one that can be started, paused, and resumed. And to make a function a suspend function, we simply add the suspend keyword to it just like so. So we do that, the red line goes away. We still have to return something, we still have that red line, but we're making good progress here. So next, let's declare our retrofit service. Now, what do we have going on here? I went ahead and typed it out so I could explain it one line at a time. First, let me take care of my red lines. I'm going to Alt-Enter and import iPlantDAO. So RetrofitClientInstance, remember what that is? That's the class that we made just a moment ago. Now, RetrofitInstance, what's that? Well, that is this essentially internal variable that's a singleton object. If you're familiar with singletons, it just means there will only be one of these. And we can access it easily using this dot notation. Then question mark means it could be nullable. And then create means, okay, what DAO should we use when we're using retrofit? And which DAO are we using? This iPlantDAO that we just created. We have a funny syntax here because the create function needs a type. It needs essentially a class. So to specify a class as a type, as opposed to an object, we use the class name, or in this case the interface name, ;class.java. In Kotlin, that's just how we specify a type literally. So that gives us our service. Now what we can do is we can actually run this network operation on our separate thread. Service.get all plants. Now that's interesting. You see, service is this retrofit instance create so on and so forth, but it knows about our get all plants function. And where did that come from? Well, that's the function we created right here. So we can connect the dots and realize what's happening is we are calling get all plants, which is going to go out and get our data. Now, a couple things we need to do, though. We need to do this asynchronously, so we're going to wrap this into an async block. Asynchronous means basically go do this and let me keep running on my own. Let's assign the results of this to a variable called plants. Now, what we need to do is we need to wait for that call to come back. We can say plants.await, which means we're waiting for this call to come back, question mark dot, and then await response. So we want to get the response. Once again, question mark period, and then body, which is going to return to us. Actually, look very carefully when I type in body. Look at the return type. The return type is an array list of plants. So finally, after all of this, we've spawned the call in a new thread, and we are receiving the results back. So let's store this in a variable called results. And then when we're all finished, we can return results. We have to do something a little bit tricky, though. We can't just do a return. We have to say we're returning from within this withContext block. So return @withContext and then result. And that's effectively going to take this result and return it back from here. Result. There we go. But we still need to return from the fetch plants function. So this entire unit is going to return the array list of plants that are captured here, and to take what this gets returned and to have the grander function return it, we simply add the word return before the withContext. And now guess what? Everything compiles. Now for the moment of truth. Since this is test-driven design, let's go ahead and run our test and see if we have fulfilled our obligations of making the test pass. And sure enough, you notice that the test does pass. Let's slow it down a little bit and run it in the debugger and see what we get. Notice it starts at our given. We'll go ahead and continue. Now it's doing the suspend function when plant data are read and parsed. And now it's in then the plant collection should contain Cercis canadensis. We'll go ahead and step over this one at a time. Take a look at all plants and you notice that it has 5,950 items in it. And so sure enough, we are definitely getting data back. You can see genus, species, cultivar, and common where those exist. Different plants have different attributes, but nonetheless, you can see that these are getting populated from the JSON data source. So we go ahead, we step over. Now it's going to go into a for each loop. And as I see this, I realize I probably should have put a break in here because it has to iterate over 6,000 plants and see if any of them are Cercis canadensis. Now at this point it has stopped for a moment because I put a breakpoint in this if test if the if test is positive. And sure enough, you see Cercis canadensis eastern redbud. It has found our eastern redbud. So I'll go ahead and let it continue, and it will probably find a few more, so I'm going to remove that breakpoint and then we'll let it continue. And sure enough, we see test pass. Everything looks good. So in this video, we've explored how to use Retrofit to easily parse JSON to a plain old Java object or to a Kotlin data class. And we've seen how to do it with test-driven design. I hope this video has been helpful, and I look forward to reading your comments. Thank you.